Number 22. A doubly charged ion is accelerated to an energy of 32 kilo electron volts by the electric field between two parallel conducting plates separated by 2 centimeters. What is the electric field strength between the two plates? So what do they give us? They tell us a doubly charged ion. Well, what does that tell us? That tells us that the charge is going to be double that of a base charge. And remember, a base charge, like a proton or an electron, has a value of 1.6 times 10 to the minus 19th coulombs. Okay? So what we're going to do is we're going to just multiply that by 2, basically. So this comes out to 3.2 times 10 to the minus 19th coulombs. That's going to be the charge that we're working with. Okay? Whether it's positive or negative, it doesn't matter. The magnitude is what is important. Now it also tells us then that the energy, okay, so I'll just label it as E, that it was accelerated to an energy of 32 kilo electron volts. So 32. Now I can do this probably in electron volts, but I like to work with the standard coulombs and joules and all that, okay? So kilo electron volts. So now what I realize is I need this in terms of like joules. Remember, electron volt is a unit for energy, and 1 electron volt is equal to 1.6 times 10 to the minus 19th joules. Interesting. Look, the numbers, okay, look very similar, but the meaning is a little different. So what I'm going to do here is I'm going to first realize that I have kilo electron volts. So I'm going to put kilo electron volts on the bottom, electron volt on the top. There will be 1,000 electron volts for every 1 kilo electron volt. So that goes bye-bye. And now I can convert out of the electron volts by going from electron volt to joule. So 1.6 times 10 to the minus 19th over 1. And now bye-bye electron volt. And now we can just do this, right? So we got 32 times 1,000 times then 1.6 times 10 to the minus 19th. And we get a value of about 5.12 times 10 to the minus 15th. And that's now in terms of joules. So that's the energy. If this is the energy it was accelerated to, well, that means it must have had some potential energy at the start. And therefore, conservation of energy tells us that whatever energy it had at the end had to be equal to the energy that it had at the beginning, right? Assuming no frictional losses of sorts. So that means this is actually the energy can be considered the change in potential energy of the object. Okay? So now that we have a charge and we know the change in potential energy, what can I find? Well, it turns out that I can find the voltage because I know the formula, right? It turns out I can find the voltage. So the voltage, or the potential difference, in other words, is going to be equal to the change in an object's potential energy, all divided by then the charge. Change in potential energy we found was 5.12 times 10 to the minus 15th joules. Divide that now by the charge, 3.2 times 10 to the minus 19th. And let's see what we get. So we got that value divided by 3.2 times 10 to the minus 19th. And this comes out to about 16,000. Okay, so in other words, 1.6 times 10 to the 4th volts. Okay. Now that I know voltage, right, so now change your perspective. Now that I know the voltage, and now they're also telling me that the plates are separated by 2 centimeters, can I now find that electric field strength? Sure. How do we do it? The formula. The voltage between two plates A and B will be equal to the constant electric field between them multiplied by the distance between the two plates. So, all I need to do is algebraically solve this for E, meaning divide out D from both sides, so it's voltage over distance, plug in the voltage of 1.6 times 10 to the 4th, divided by the distance between them. Remember that needs to be in meters, so 0.02. And voila. So what is that? 800,000. Okay, and I guess what? 3 sig figs, 2 sig figs, whatever. So this is 8 point, right? Don't you feel that way like towards the end? Towards the end of physics, aren't you like, oh my God, sig figs still? Who cares? 8.0 times 10 raised, I'm running out of space. You're probably like, if you think I felt that way at the end of physics, imagine how I felt at the beginning. Yeah, I know. I've been there. 8 times 10 to the 5th. And that's going to be in terms of now volts per meter. Just double checking. Cool. So everything looks good. That's the electric field strength. All right, guys. Hope you are having a good semester at least, and that it's not stressing you out too much. But if it is, I hope this is maybe providing a little less stress or a little more clarity. So hope we're able to help you out. Okay? And I look forward to seeing you in the next problem. Take care.